Astronomers have discovered the biggest galaxy known to date, and it's so big it will break your brain. It's a radio galaxy lying 3 billion light-years away from us in the constellation of Lynx. This means that light from this galaxy, traveling at 300,000 kilometers per second, takes 3 billion years to reach us. This mammoth galaxy has been named Alcyones, and it has puzzled astronomers. But what is a radio galaxy? How is it different from the galaxy we live in? And most importantly, how big is it compared to the Milky Way? Our journey of exploring galaxies has been an interesting one. About a century ago, we believed there was just one galaxy in the entire universe, the Milky Way. Of course, we had pictures of other galaxies, like the Andromeda Galaxy, but astronomers believe them to be stellar systems of the Milky Way itself. 100 years later, the number has gone up to 2 trillion. Astronomers have seen a variety of galaxies in the universe. They include spirals, ellipticals, irregulars, lenticulars, lopsided, interacting, and merging galaxies. But this is an apparent classification based on what we see through a telescope in the visible region of the electromagnetic spectrum. Objects in our universe radiate energy over a wide range of frequencies, and depending on this energy emitted by them, they show varying luminosities in different sections of the electromagnetic spectrum. This means that there might be an extremely dull object in the visible spectrum, but can appear very bright when seen in radio or infrared light. So the galaxies that are very luminous at radio wavelengths are known as radio galaxies, and Alcyones is one of them. Now the question is, what makes radio galaxies unique? What extra information do we get when exploring the sky and radio frequencies? Radio emissions are one of the best ways to decode the mysteries of our universe. As radio waves have longer wavelengths, they can also travel through dense dust clouds, thereby providing unobstructed views of the cosmos otherwise not visible in the optical spectrum. There are different emission mechanisms via which astrophysical objects emit radio waves. However, the most common emission mechanism is the synchrotron emission phenomenon, and most radio galaxies majorly emit radio frequencies due to this phenomenon. Now what's that? You must have heard of cyclotron radiation in your high school physics classes. When electrons moving in a circular orbit in a cyclotron get accelerated in the presence of a magnetic field, they emit radiation corresponding to their cyclotron frequency. Now, synchrotron radiation is just the relativistic twin of cyclotron radiation, as electrons, in this case, are traveling at relativistic velocities. Hence, synchrotron emission is one of the most powerful and dominant mechanisms of radio emissions. Like other galaxies, radio galaxies consist of a host galaxy, comprising stars orbiting a galactic nucleus containing a supermassive black hole.